So let's have a look at the periodic table here. Everything on this periodic table is an atom, and atoms are neutral. They don't have any charge. And what we're going to look at in this video is why metals tend to gain a positive charge and non-metals gain a negative charge. Now the non-metals are found up here, and we're just going to look at a few of the most common ones. So we'll look at these few here. The metals, of course, are all of these over this side of the periodic table, but we're just going to look at some of the most common ones from group 1 and group 2 here. Now this periodic table, I've cut it down a little, taken out this middle section. This is the transition block, or the transition elements. I've just removed that, so we're left with a slightly larger, slightly bolder table. So the ions or atoms that we're going to look at are these here. These are group 1. So you can see I've got lithium here, sodium, potassium. You may notice there's a pattern with these atoms already. They've all got one electron in their outer shell, and that's quite a coincidence because they're all in group 1 and they've all got one electron in their outer shell. In fact, that's the reason they're in group 1, that they all have similar properties because they all have one electron in their outer shell. So group 2, we've got beryllium, magnesium and calcium. You see here, of course, they've all got 2 electrons in their outer shells. Okay, let's see what happens to these atoms when they become ions, and let's try and look at the reasons for the charge they gain. So lithium is here, it's in group 1. And it has a atomic mass of 7, has an atomic number of 3. So we know from that we can work out the number of protons, neutrons and electrons. It has 3 protons, so that equals the bottom number. The number of neutrons we get from taking the atomic number away from the atomic mass, so it has 4 neutrons. And then the electrons, we can work out that it must have 3. Because if an atom is neutral overall and it has 3 positive protons, it must have 3 negative electrons. So what we need to think about now is stability and the reasons why lithium may gain or lose electrons. Every atom, every ion is trying to gain either a full outer shell of 2 in the inner shell, or the next shell is full if it has 8, and the next shell full if it has 8. The only atoms in the periodic table that have this is the noble gases here, which are group 8 or group 0. Everything else on the periodic table is trying to achieve this electronic configuration, or this arrangement of electrons. So if we look at the lithium ion, it still has the same symbol, it's still lithium 7 and 3, but now it's going to try and either gain or lose electrons. It could gain 7 to get a full second shell of 8, or it could just give 1 away, and 1 seems like a much easier option. Just giving 1 away is far less hassle, and that's what lithium does, it just gives away 1 electron. So we need to look now at how many protons, neutrons and electrons it has. Now nothing in the nucleus changes when we're doing chemistry, and when we're looking at ions, it's only the electrons change really. So the protons are the same as it was before, the neutrons are the same as they were before, but the electrons of course have changed. It's lost 1 electron, so the electrons are now 2. So there must be a charge on lithium now. It's got 3 positive protons, 2 negative electrons, so overall there's going to be 1 positive charge on lithium. So to show that, what we do is put some brackets around the ion, and then we can say it has 1 positive charge, or +1, or 1 plus positive charge. So let's have a look at some more examples. We've got beryllium here from group 2, and if we write down the details of beryllium, we can see it's beryllium, it's atomic mass of 9, atomic number of 4. So it must have 4 protons. The number of neutrons must equal 9, take away 4. and the number of electrons will equal the number of protons, so again 4, and you can see that there I've drawn 4 electrons. So let's see what beryllium wants to do when it becomes an ion. It could gain 6 here to get a full outer shell, or it would be much easier just to lose 2 electrons. So there we go, beryllium has achieved a full outer shell. It is stable. Let's write down the details of what's inside beryllium. It still has 4 protons, still has 5 electrons, but now, 5 neutrons, but now it has only 2 electrons. So it's lost more electrons. So it's got 2 more positive protons than it has negative electrons. So we know that the charge must be 2, and of course it's positive 2, so beryllium has a charge of 2 positive. Okay, let's look at some of the non-metals now from over here. So we've got shown on the screen here oxygen and sulfur, both found in group 6, and then some of the halogens here which are found in group 7. So we've got fluorine in group 7, and it has 1, 2, 3, 4, 5, 6, 7 electrons in its outer shell. It's in group 7, so it has 7 electrons. Let's have a look to see what is in fluorine. We've got 19, 9. So the protons are 9, neutrons are 19, take away 9. Electrons must be the same as the number of protons. Of course, fluorine wants to become stable, and it can do that by either getting rid of 7 electrons, which seems like a lot of hassle, like a lot of hard work, or it could quite simply just gain 1 electron, and that's what it does. So let's see if we've now got 9 protons, 10 neutrons, and of course it's gained 1 electron. It's got 1 more electron than it has proton, so that means it's got 1 negative charge. So just like with the metals, we draw the brackets around the ion and we say it has 1 negative charge. You notice the difference between the non-metals and the metals. The non-metals gain an electron to get a negative charge, which is in contrast to the metals which gave away electrons to get a positive charge. So let's have a look at some more. We've got oxygen here again, that's in group 6, so 6 electrons in its outer shell. Oxygen 16 and 8. And the electrons again match the number of protons because an atom is neutral. It wants to gain a full outer shell. It's only got 6. Giving away 6 seems like a lot of hard work. So what it does is it gains 1, 2. So the ion is still 8 protons, 8 neutrons, electrons, has gained 2. 2 more negatives than it has positives. So we note that an oxygen ion will have 2 negative charges. Sulfur is in the same group, and we can probably start to predict now what the charge on a sulfur ion is going to be. We don't need to go through all the hassle of writing down how many protons, neutrons and electrons there are. Let's just have a look. It's got 6 electrons in its outer shell. It needs another 2. 1, 2. So we know it's going to have 2 more electrons than it has protons, so sulfur 2 negative charges. Chlorine is in group 7. It's going to behave in a very similar way to fluorine. So it's got 7 electrons in its outer shell in the atom. The ion, it needs 1 extra electron. There we go. It's got 1 extra electron. It's become stable. It's got a full outer shell. That 1 extra electron gives it 1 negative charge. So if we predict the charges on some of these atoms, we can see calcium, it's got 2 electrons in its outer shell, as you'd expect, it's in group 2. So if it gives away 2, it's going to have a charge of 2 plus, 2 positives. Potassium has only got 1 electron in its outer shell. It's going to have a charge of 1, positive 1. Sulfur needs to gain 2. And bromine, of course, will gain 1 because it's in group 7. So if the non-metal is in group 7, it will end up with 1 negative charge. If it's in group 6, it will end up with 2 negative charges. Group 1 metals will have given 1 electron away to become stable, so they'll have 1 positive charge. Group 2 metals will have given away 2 electrons to gain 2 positive charges. That's ions.